Hello everyone. In this video we'll be discussing interfacing and decoding motion sensor with Arduino, that is P.I.R. sensor. Here is the learning outcome. At the end of this session, students will be able to interface motion sensor with Arduino and decode the communication protocol used by logic analyzer. Here is the interface diagram. There might be a slight change in the actual practical circuitry or the physical connections that we are about to see in a short moment.
Okay, so here is the setup. In this experiment, we are going to use this Arduino board and a motion detection sensor. As you can see, this is a special type of a sensor which is covered with the Fresnel lens, and if I try to detach this Fresnel lens, you can see that there is a small IR sensor present inside this. This is basically a passive infrared sensor, and the light or the light incident rays that are being emitted out of this particular sensor or the transmitter is going to reflect or is going to pass through this Fresnel lens, and that creates a specific pattern such that whatever reflected signals are echoed back and they are incident on this particular lens, they reach this particular sensor in a specific way such that the time difference can be easily identified. So without the presence of this Fresnel lens, it becomes a little bit tough or infeasible to make any circuit based out of something like this. So let's move ahead and try to interface. As you can see that there are 3 pins to this P.I.R. sensor. So the red one is VCC out and ground. So the red one goes to the 5 volt, and the leftmost wire goes to the ground, and the center one, which is the out signal, goes to any of the digital pins. So let's go for pin number 2. Usually we don't connect pin number 0 and 1, because if I use it, then I need to every time keep it open while I'm programming. Once the programming is done, I need to put it back. So rather than dealing with the programming pins, that is 0 and 1, and trying to interrupt the programming thing or the stuff while we are exactly programming this microcontroller, it is always a good moment to think on it and keep them blank. So along with that, as we have been using this 8-channel Solay logic analyzer, this time also I'm connecting channel 0 to this red wire, which I'll be using to scan the signals coming out of this P.I.R. sensor. And I have a ground connection. This ground connection would be connected to the Arduino ground pin, so that we have a proper balance between the voltages of these communicating devices. Now heading back towards the board, let me open a fresh window. Let us set up a serial communication of 9600 baud, and let us define pin number 2 that we'll be using as an input, and I'm trying to just print the status of the pin to which our PIR is attached. So in case if the PIR sensor is having any sort of obstacle, or if it has detected any sort of obstacle, then it is going to give a high pulse on its output, and hence it is going to pass on a high signal on its pin number 2, and probably we should be reading a true signal on our serial monitor window. So let's try to do this, and always don't forget to put some good amount of delay so that you can spare some time to analyze the output, otherwise there is going to be continuously rolling up. So I think this small program is enough. Let us check the COM port to which our controller is connected. That's COM7, and I'm trying to upload it again. I'll call it PIR. So just to be sure that the sensor is working perfectly, you need not to place any obstacle in front of it, at least by some distance. So usually this works in a distance of 6 to 7 feet. At the max, what I have tested is 10 feet. But you can adjust the sensitivity and the timing between which the triggers can be given out of this particular signal by controlling these two potentiometers, which are available embedded on this breakout board. As you can see, the status program is successfully uploaded. Let's have a look at the output serial monitor. Okay, currently it is 0, but when I place my hand in front of it, you can see that it is displaying 1. As soon as I remove it, you can see that it is displaying, it should be displaying a 0. Yes. So we need to leave it alone for some time. So this is a very important thing, and if I hold my flashlight in front of it, sometimes there is a possibility that it can capture the lighting or any sort of UV radiation that is coming or which is incident on this particular sensor as a false positive. So just to avoid these kind of faulty behaviors of the sensor, basically the sensor is designed in such a way that unless and until there is some sort of movement, that doesn't trigger the output pulse. But in case if you are using a normal IR LED, then probably that is going to create some noise, especially when you are dealing at daytime under sunlight that behaves differently, and under dark light that behaves something differently. For that we have a solution, that is we can use some modulated sensors, something like this, which we'll be having a look at in our next video. So as of now, we don't need this logic analyzer because anyways we are able to see the output on our serial monitor. So this is how we can decode in what language the sensor is communicating. So basically the output that this PIR sensor is giving us is in a binary format, either it is a 0 or 1. So whether we are connecting this logic analyzer or not, that doesn't make any difference. So that's all for this experiment.
Here are the references used for this video. Thank you.